Do you know what frequency means? If I talk about the frequency of someone being in class, what does that mean? What is it? Energy? No, but that's a good guess. The frequency of someone being in class. Anyone? It's how often they are in class, okay? So here, frequency means how many, okay? How many times, how many people, how many of whatever, all right? So let's take a look at this. This is a frequency table. People were asked how many hours of sleep they got the previous night. The results are shown below. So in this particular problem, when it's talking about hours, we're talking about the amount of sleep. Okay? Amount of sleep. Have you been getting more sleep, Umu? Have you been getting more sleep? I remember you said the first day. No? You said you went to bed like at 3 o'clock. You're just not a big sleeper, huh? Well, you took a nap the other day, though. Okay. All right. So this means that we had one person say that they slept 6 hours. We had some people say that they slept 6.5 hours, and that was 3 people. All right. 5 people said they slept 6.75 hours. 2 said 7.25. 1 said 8, etc. 2 people said they slept 9 hours. Sometimes we will put a tally, okay? So we might have numbers over here like 6, 9, 8, 6.75. And what we would do is put a tally here. That's what this is. And we would count up the number of times that they had it. But we don't have that here. I'm just saying that's what they do sometimes. Okay? So let's see if we can answer these questions at the top. Label each column, remember goes down, of the table to state what it means for the situation. So we've got amount of sleep in hours, and we have how many. Actually, it's not how many times, it would be how many what in this situation? How many, no, not how many hours. People were asked how many hours of sleep they got, so it would be how many people, right? So here we're counting people. So you might want to change that. All right, so it says how many total people, total is a key word here, are included in the survey. What does total imply? What operation? Addition, subtraction, multiplication, or division? Addition. So we're going to add. How many total people are included in the survey? What am I going to add up here? The people, okay, and the people are in the frequency column, right? So we are going to add all of these together. I want you to add them up very quickly. Add those up. I'm not going to do all the work. Let's see if we can get the same answer. I forget what the correct answer is. All right, what'd you get for a total, Daniel? 15. What did you get for a total, Lennon? 15. Who haven't I talked to? Aslaney, what did you get for a total? Okay, good. You guys, we all got the same thing. That's fantastic. Yes, there are 15 total. Might want to put that down at the bottom so you know where you got that. Now, this says, what is the minimum data value of our data set? We're trying to figure out how many hours people slept. So the minimum means, does that mean high, low? What does that mean? The low number. What is the low number of our data set? Yes, very good, because we're talking about the amount of sleep that we get. So this is my lowest, which is 6. So what is the maximum going to be? 9. Yeah. Now, does that mean the maximum of all time? No, but it is the maximum for our frequency table. Okay? Is this making some sense? All right. So we just got so many of those questions done. Now we're going to take it to a next level and let's talk about the probabilities. So express them in reduced fractions. So we do have to make them simplified. What is the probability that a person slept for 6 hours? Okay, we know we're going to put it in fraction form. What is my denominator going to be? What is it? 15. Yeah, because that's the number of people that participated. So that's going to be your denominator for all of them. Now, it says out of those 15 people, what's the probability a person slept for 6 hours? Well, as I look at 6, how many people slept for 6 hours? 1. So that means 1 goes up here. Is that in simplest form? Yes. Yes, it is. All right, what's the probability a person slept 6.75 hours? Let's put the denominator in. What's the denominator again? 15. Oh, you guys are so smart. 6.75 hours. Find that. What is that number for my numerator then? 5. Excellent. You're feeling pretty good. Is that my final answer? That's a really good answer. Is that the best answer? Survey says no. We can simplify that. Divide by 5 over 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 1/3. A third of the people slept 6.75 hours. I wish I could sleep 6.75 hours. All right, and the last one. What's the probability a person did not sleep exactly 8 hours? Ooh, this is like that not. Remember the not? So we would take 1 minus the probability that someone did sleep 8 hours. Do you remember that? The not? So 1 means 1 whole. Okay? That means I'm talking about 15 people. So 15 people minus how many slept exactly 8 hours? Come on, you can say it. 1, thank you. So 15 minus 1 equals 14. That's the numerator part. And what's my denominator? Over 15. And there's your final answer. Okay? Now, if I know that this 1 does not or is the only one that sleeps 8 hours, do you know how else I could find that answer? You could add all of these up because they are not that 1. If you add them all up, you would get 14 out of 15. Any questions on that top part? All right, let's take a look at the bottom. Another frequency table. Students were asked how their scores or how they scored on the semester 1 final exam. Results are shown below. So we have scores. This is on the final exam. And frequency. What is this frequency talking about? Number of what? Come on, number of what? What are we talking about? Say it again. Final scores? Sort of. We're talking about number of people, right? Number of people who scored in that range. So how many total students were surveyed? See if you can write that down. How many total? Ooh, there's that word total. I know total means I'm going to add, so add those up. Wait a minute, which ones am I adding up? Which ones am I adding up? Oh, you're lucky. How you doing back here? Doing all right? Look at you. That's great. All right, how many total students am I talking about? Guys, come on. 20. Where did we get 20? You add these all up over here. We just said that's the number of people. And when you add them all up, you get a total of 20. All right, what's the probability that a student scored between 60 and 69? Marvin, you look sleepy. Are you okay? What's the probability that a student scored between 60 and 69? How many scored between 60 and 69, class? 2 over 20. 2 over 20. That is a really good answer. Is that the best answer? No. Divide by 2 over 2, and we get 1/10. 1/10. That's the best answer. Okay. Next one. What is the probability that a student passed the final? They passed the final. They got a 60% or higher. Well, first of all, what's my denominator going to be at the very beginning? 20. Does everybody understand how to get that? Montre, do you understand that the bottom number is 20? Do you understand the bottom number is 20? All right, do you understand the bottom number is 20 here? 20, 20, 20. All right. So there's my 20. I need to get a 60% or higher. How would I calculate that? What am I going to add? Yeah, you're going to add all of these together because that is 60 or higher. 60 or higher. So 2 plus 6, 8, 8 plus 7, 15, 15 plus 3 is, what do we get? 18. That's a really good answer. Is that the best answer? No. Divide by 2 over 2, and we get 9/10. 9/10. What's over there? Okay. 9/10. Did anybody do it a little bit differently? Anybody at all? Anybody say, hey, I know all of these, I have to add these up. Well, if I just take 2 away, did anybody think of that? Wouldn't that be the same? Yeah, 20 minus these 2 gives you 18. Any questions about frequency tables on this page? No? Okay. All right, let's turn the page. And we have a half page called the Fundamental Counting Principle. This is a fun little trick. Daniel, you look good. Okay? Fundamental Counting Principle. Sometimes we call it the FCP. FCP. Daniel, you're with me, right? Okay. So what is the Fundamental Counting Principle? I am not an English person, so I often have to go to my notes to make sure I don't give you any incorrect information. So, the Fundamental Counting Principle is a rule used to find a rule used to find the total number of possible outcomes. The total number of possible outcomes. A rule used to find the total number of possible outcomes. Okay. Then it says we have a number of choices event. What? Just go with me for a minute. Which is the number n, or whatever that number happens to be, times the number of choices event m. And if we had more, you could take it times another number of choices. So it's about the number of choices that you have, and they are multiplied. Now I know this says total, but repeated addition is multiplication. Okay? So let's take a look at this. For example, says, suppose you bring 4 shirts, 2 pairs of pants, and 3 pairs of shoes on vacation. How many possible outfits can you create? Well, let's write these down. I have shirts, I have pants, and I have shoes. Okay? The number of choices for each category is what you write down for the numbers. So how many shirts do I have to choose from? 4. Boy, that was a weak 4. But thank you to whomever said that. How many pairs of pants do I have? Boy, come on, guys. 2. I should hear 2 from everybody. You have 2 pairs of pants. How many pairs of shoes do you have? Okay, I got a couple people. Man, tough crowd. 3 pairs of shoes. How do I get my answer? You multiply. 4 shirts times 2 pairs of pants times 3 pairs of shoes. 4 times 2 is 8, and 8 times 3 is 24. You're like, really, Miss CD? Are you sure about that? I am. Okay? To find the total number of possible outcomes for every event you have, you are going to multiply. Let me tell you, this isn't difficult, is it? Just say no. The problem you're going to have is some of you are going to be like, do I add? Do I multiply? You need to remember you're going to multiply. Okay? So let's look at number 1. You go to the snack bar to buy a bagel and a drink. You can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or a sports drink. How many different lunches can be made with these choices? So, what are your choices? You are getting a bagel and you are getting a drink. Now, did they give you a number for how many bagels there are? So no, you are going to have to read. How many different choices of bagels do we have here? How many? 3. You have plain, blueberry, or raisin. So that's 3 choices. How many different drinks do you have to choose from? Water or a sports drink? That's 2. What am I going to do in between? Multiply. 3 times 2 is 6. So you have 6 different lunches there. Questions on that? You get ready to get dressed for school. You open your closet. You have the following choices: a red, blue, or white shirt. jeans or sweatpants, tennis shoes or sandals. How many different outfits can you make with those choices? Well, let's see. We got shirts, we got pants, and we got shoes. How many different shirts do you have to choose from? Angel, how many different shirts? Doesn't give you a number. 3, yes. We got red, blue, or white. 3 shirts. How many different kinds of pants do you have to choose from? 2, excellent. And how about the shoes? 2. All right, what am I going to do with all these numbers? Multiply, fundamental counting principle, and that's going to give you the total number. 3 times 2 is 6, and 6 times 2 is 12. Any questions on that? Wow, this is really easy, Miss Dee. It is if you remember to multiply. Cafeteria for lunch, you have a choice of 4 entrees. 4 entrees. 5 sides. Oh, geez, I can't even read. 5 drinks. 5 drinks. And 4 desserts. Okay? Brandon, you cannot pick all desserts. Sorry, you have to pick one from each category. All right? So when I multiply, okay, I multiply these all together, and a couple ways you can do this. You can say 4 times 5 is 20. 20 times 5 is 100. 100 times 4 is 400. 400 different choices. That means you could have the sloppy Joe with the French fries, with a Diet Pepsi, and a piece of pie. You could have 400 different things before you would repeat and come back to that same 4 things again. That's what it means. Okay? Any questions about the fundamental counting principle? All right. Please take out homework number 1. Please take out homework number 1. That should be the last packet. Maybe you've started it, maybe you haven't. Looks like this. Okay? Does anybody lose theirs yet? Looks like this. This is due tomorrow. This is due tomorrow. So I want you to take a look at this right now, and I want you to get started on it. Okay? Number 1 says 200 students were surveyed about their favorite animals. Results are displayed below. What's the probability that someone had a dog? Okay, just looking at that, it tells you 200 students were surveyed. What is your denominator going to be at the beginning for each one of these? 200. Now, is that the final answer? Not necessarily, because maybe you can reduce. All right? So, what's the probability that someone had a dog? Let's do that one together. Someone has a dog. What's that probability? 79 over 200. Can that be simplified? I don't think so. So I would just leave it. 79 over 200. Miss Edie, are you sure? Is that it? Yeah, that's it. 79 over 200. All right, what's the probability of cats? Is that cats and, or is that cats or? That's an or. So we want all people who love cats or own cats favorite is cats. All freshmen, but we need to take away the ones that are in the intersection. Okay? And then we put it over 200. And if we can simplify it, we simplify it. Okay? This is due tomorrow. Front and back. Alright? Just give it a try. Alright, Angel. I want to see